Alrighty, welcome back. This is hopefully a relatively quick video. I'm verbose, so I have a tendency to run long, and I apologize for that, but I like going over stuff again and again and again and again, and if at some point you're thinking to yourself, Spike, I've already heard this, I know this, move on, well then that's good, because it means that you understand it. So I'm revisiting data types, specifically in Java, and focused on the ones that you're most likely to be working with in your assignment, with the exception of arrays, because there's already a couple of videos that go over arrays pretty extensively. So from that, maybe you don't even need this video, but we'll do it anyway. So anytime you go to declare a variable in Java, you have two things, probably three, that you need to do. So first, you have to declare it. You have to tell Java that it exists before you can do anything with it. So if you remember from the code breakdown, our declarations first involve specifying the data type for the variable so that Java knows how to interpret the bits and bytes. And then it has to have some name, which can be more or less any series of letters, numbers, and underscores. It has to start with either a letter or an underscore, and usually you want this to be something human readable that gives you an idea of what it's for. So let's say that we have an integer that's going to be number of eggs. I don't know, we're using, it's a poultry-based program, and we're dealing with the number of eggs. And then, so this part in and of itself, right here, we could stop, and this is a valid declaration in Java. However, until we have assigned a value to this variable, it cannot be used. All right, so right now it's in, it exists. We can reference it later without specifying its type because we only need to do that once. But before we can try to pull a value out, we have to put a value in, just because otherwise, similar to going off the end of our array, there's just junk inside of number of eggs. So it might not be a value that is safe for us to compute on. So we can do number of eggs equals, we can put an int literal, meaning that just some text that represents that value, to assign it to 2. We can do that on the separate line, because once we've declared it, we can use it in an assignment whenever we want to. And we can also do this, like you saw in the code breakdown. We can do this on the same, as part of the same statement as when we created it. So we can, integer number of eggs gets or is assigned the value of 2. And this value 2 could be anything that is actually just an expression that's going to give us 2. And it rather not just 2, but any integer value. So in this case, we have a literal, meaning I've typed into the code a just text that represents the value that I'm talking about. But if I had some other variable name, and I know that some people don't follow this, but if we just had some variable named foo, now I haven't actually created one anywhere, so this won't compile, but this could be a variable that also contains an integer, and that's perfectly valid. Or it could be a method call that would return to me some integer value that could also be assigned here. So any expression that would give me an integer value is acceptable on the right-hand side of the equals. And that could be, like I said, it could be anything. So here we have 2 plus 0. So now granted, this isn't doing anything for us, right? All we're doing is just showing that the function of addition, on 2 and, on literal values of 2 and 0 could be put here as well. So it could just be some kind of arithmetic expression that is going to give us an integer. Any of those different ways can be used to assign a value, and we can assign it whenever we want to, right? So we can change number of eggs, and here will be an example of we can use the same variable in its own assignment because we've given it a value. So what will happen is everything on the right hand side of the equals will be evaluated. Whatever value comes out of that is then assigned into number of eggs. So we can't actually, we don't have to worry about number of eggs changing while it's on the right hand side. So it's always going to evaluate this variable. It's going to pull out the number 2, and then that's going to be added to the value of whatever this currently undeclared, so it isn't valid yet, but whatever the value here would be. Or we could just maybe add 1 to it. We assume that we suddenly just got one more egg. So either of these things are valid, and we could use number of eggs on this right hand side of the equation however many times we wanted to. And again, we can change number of eggs anywhere after we've declared it. So, but something to be aware of is that number of eggs only lives or exists inside of sample method, because we declared it inside of this scope, right? When we look at these curly braces, that kind of tells us what scope we're talking about. Anything inside here can use number of eggs after it's been declared. We couldn't use it up here because it doesn't have a value yet. And it's also, this doesn't happen to be a normal statement. If you remember the syntactic sugar to increment some value by 1, the plus after the variable name, that becomes a statement, but now cannot find symbol variable number of eggs. So if you see that when you're working on your assignment, it means that you either haven't declared the variable yet, or you meant to, and just in one place or the other, you haven't spelled it exactly the same. These are case sensitive, and all that matters. So if we took off the egg there, then this suddenly changes, and now it doesn't know. Rather, that's not the best place to make that example, but if we removed it from, say, here, now we meant to, but this declaration doesn't match this usage, so it doesn't know that it doesn't have this variable in its symbol table. So integers are the primary thing that you'll be using through the assignment, because we can represent the index into an array using an integer, and the values that we're putting inside of our list that we're going to search for are also integers, and integers will also represent, or could be used to represent the length of the list that we're searching through. So any of those things are possibilities. In addition to that, you will probably want to use a boolean somewhere. And booleans are just true or false. And so here this is the the Boolean literal of false, or it could be true, and those are our options. And the reason that you'll probably want to use one of these is, as mentioned in class, we could use a which, or while, I'm sorry. There is a which, but that ain't going to help us right now. So we can use a while statement to do the same process repeatedly, right, as we're searching through our list for a certain value. So what goes in here is any Boolean expression, right? So anything that, once it's evaluated, returns true or false, will control whether or not this loop executes or doesn't execute. So right now, well, there's nothing inside of there, but we could put a Boolean variable in here, and this is a valid Boolean expression, right? So this would be saying, the value of has answer, which currently is false, which means that this while loop wouldn't execute. So because we'd be saying while false and then nothing. However, if we liked the way that this reads to us, right? So if we're looking to see, have we found the answer, meaning have we found the value that we're looking for? No, we haven't found it yet. Then this is a good precursor to our actual looping to look for the value. But logically, has answer starts out at false and will never loop. So if we put a bang in front of it, we will invert the logic of that variable. So has answer is false. When we change this now becomes true. And if I go ahead and, whoops, just to make this compile, just to show you, we're just like we had on the arrays example, we're now inside a forever loop because we have said while not has answer, which is false, so while true, do nothing at all, and it just keeps doing this forever. So we're going to have to go into our debugger and kill the program. Oops. And we'll just clear that because it's really ugly. There we go. And then we can close the debugger. So the point of doing this is to illustrate that if we're using a Boolean variable up here as part of the information that goes into controlling whether or not our while loop executes, then we need to have some statement inside of the while loop that is going to change the value of has answered. All right, we're gonna change it to true at some point. Now here I'm just saying, bam, has answer equals true. So this means that this loop is only going to execute one time, because as soon as we go in here, we're going to change it, and then when we go to re-evaluate the while loop, has answer is true, we invert it to make it false, and then we don't do anything else. But you'd more likely have some condition, right, such as actually finding the answer that you wanted. Right, so if cool thing we want, like finding the number, and that's just some pseudocode there because we're focused more on how the variables work and a little bit less on the logic. But this would just be some, whoops, I've actually commented all that out so it won't compile right now. So let me just not do that. So if true. So in this case, again, if we just say this if statement is always going to have a true in it, then we would have the same results, right? This while loop would only execute once. So instead, you'd probably have a comparison. So talking about our list that we would have had, and if you've gone through the other video, this will make more sense, but if you did something to the effect of if list index, and remember that our numeric comparison, right, between two things is double equals, let's say target number, and this would be the name of some variable that contains the number that we're looking for to begin with, which currently hasn't been declared, but if we said, if we did that, then now our target number, like what number we're looking for, becomes an argument to our currently named just sample method. And so if the value inside of the list, which is also another variable that we haven't declared, so this will not compile. But if this value were equivalent to whatever the current value of target number was, then we would change, has answer to true, and we would stop this loop from continuing. So when we have this kind of construct with some variable on the inside of the declaration, effectively, of our while loop, we need to make sure that we have some kind of reachable statement inside of the while loop that's going to change the value of our variable so that the loop will stop. Otherwise, you'll see this forever barber line over here, and you'll have to kill your program because we never changed it, and it just runs forever. Or it could be that maybe you changed it and then some other line of code changed it right back. But so if you have some variable out here that controls when this happens, you need to change it inside here. And this is really the same thing that happens if you remember the for loop. And we'll just blow this little guy away because we don't care about him that much. But if you remember that we had 3 parts to our for loop, and you can use a for loop in your assignment. It really just kind of depends on what makes the most sense to you. And I'm going to do another video that's kind of more holistic of looking at an algorithm and breaking down what happens with it, and then deciding how do we think we're going to solve the problem, and then what kind of code do we want to try to write. So it's really just an example that's going to precede your real binary search problem to work through a different problem so that you can follow along. And the way that I'm going to solve the problem isn't going to be the same way that you might think is intuitive to solve the problem, and that's totally fine. In fact, that's great. If while we're going through the example you think to yourself, well, Spike, why did we do, why'd you do that? Why didn't you do this other thing? Then that means you're thinking like a programmer. You're so that would be good. That'd be great. So, but anyway, just to illustrate that our while loop and our for loop are really kind of the same thing. They just have a very different form. We'll just use a literal of 10. But so here, even though it may not look quite the same, and we don't have so our variable I, which doesn't have a terribly useful name because all it's doing is running from 0 through 9. That's all it's doing, and that might not be meaningful other than, hey, we want to do this thing 10 times. But so just like we had for our other, actually we'll just do this real quick. We'll just create 2 things. Now in this case we have to have, this is totally valid. Int I equals 0. Now you'll notice that I can use I again, and this will be valid because, whoops, well, we don't have an expression in here. So while I is less than 10, and then I plus plus. So right now, oh, okay. All right, we haven't created a new scope. Not really. I thought we, oh yeah, that's right, because I is already visible inside of here. There is a way to do that. I'm pretty sure it's just that. Nope, okay. Never mind me. Instead, that's just me being forgetful. It's been a while. The reverse would have been true though. So in this case, these two, this while loop and this for loop, do exactly the same thing. Really, the only thing that they do is change one variable. But if we, let's say, grab a system printout function and put these in here, and here we're just going to print these values. We're going to see both of them do exactly the same thing. Oh yeah, the reason that we see this box is we've evoked a method that has an argument, so we have to give it target number. It doesn't actually get used anywhere, which is dumb of me to have it in here and not use it, but there it is. So we can put in any number that we want because nothing bad ever, it's never used, so it can't affect how the code works. But now that we look, so this first 1 through 10, so we do see a little bit of a difference. Not much though. One of them being all right. So I has gone one additional value only because we didn't change it as the last thing. There we go. Now we will have exactly the same output. We will compile, and then again we have to give it some silly number. So here we see 0 through 9 and then 0 through 9. So these two do exactly the same thing, they just have a different syntax. So they both have a boolean expression, which is controlling whether or not this loop executes, and they have some variable that exists at the beginning of the loop. So for the while, we only have this one expression. We don't have an opportunity to create anything inside of here. So instead, we must create the variable before we start the while loop. So in this case, we're using an integer. We don't have a boolean like we did before. So we're using a boolean expression that's going to compare I to something else, and that's totally valid. There's no reason that you can't do it that way. But whatever style you use, whether or not you're using a variable that contains a boolean value, or you're using some other value and going to perform an expression here to return a boolean value, you have to have something before you begin the while loop, and then you have to have some action that's going to change at least one of the variables that's involved in your boolean expression, because if you don't, you'll never break out of here, right? If I remove this I++, this is just going to go on forever. So the for loop is doing exactly the same thing, except the very first statement inside of our declaration of the for loop creates that variable for us and assigns it a default value. We still have a boolean expression, which this could again also have been just a variable that contains a boolean value, and if we did that, we would want to have some value inside, some statement inside of our for loop that changed that variable. So it's most common that you were going to use some integer or maybe a real number, and you're going to increment it to and then use it in a Boolean expression. So just like here we changed I++, this J++ does the exact same thing, except it doesn't appear inside of our brackets. Instead, it is implicit that this happens at the end of every iteration of the for loop. So they work exactly the same way, they just have a different look and feel, and they might suit your way of thinking about the problem better or worse depending on what you're trying to do. But these are identical, and we could have some different way of looking at this. So not equals J. So in this case, rather than having an integer value, we initialize a Boolean value, not a statement. Whoops. Equals not J. That's better. I think we can do it that way. Whoops. Sorry about that. Equals true. See, I make mistakes too. Don't worry about it. Nobody's perfect. And so anyway, in this case, we're instead of using integers to control our loop by placing them into otherwise Boolean expressions, here we're just starting with a Boolean, and we're only going to evaluate the value of the Boolean J. So in this case, we're only going to do the loop once, because and you'll actually see that now when we run this, and again here's our silly number that doesn't matter, we just get true, right? Because there's no longer an integer that's involved, it's a Boolean, so you'll just see true or false. But at the end of the loop, we've just assigned J its own value inverted, which automatically flipped it. But this could be any kind of statement. It could actually be an if statement that looked for something that happened inside of this loop, and if the conditions were right, changed J to false, that caused this loop to terminate. So there's lots of options for how you want to iterate over something. It's really up to you and what feels like it makes sense. So those are the two types of variables that you're going to use in the program other than arrays. And if you haven't watched the array video, I would recommend that you do that. And you'll see some of the same kind of stuff repeated, which is reinforced. And again, if you think to yourself, Spike, I know this, why are you still telling us? Then that's good, because it means that you get it. And you can move on to something else. And more video to come. Thank you.